today we are talking about the Pythagorean Theorem. Raise your hand if you've heard of the Pythagorean Theorem before. Okay, all right. The Pythagorean Theorem, so I am pretty sure all of you 8th graders did this last year in 7th grade math. So, but the Pythagorean Theorem is like the biggest theorem in all of math, in all of geometry. It's essentially all of pre-calc trig, it's all of calculus, okay? So this theorem we use all the time in geometry, all right? And so like day 2 of geometry, we do this. And so the Pythagorean Theorem is a super useful theorem that is used to find the missing side of a right triangle. So first and foremost, it's really important that we know that we have a right triangle. So knowing that we have things that are perpendicular, we've got this right angle, super duper duper important. And we also really need to know specifically the names of these parts of a right triangle. So if you have a right angle, then the side that is opposite that right angle, the side that is directly across from that right angle, we call that side C, but more importantly, it is the hypotenuse, P-O-T-E-N-U-S-E, the hypotenuse. Write that down. The hypotenuse is the most important side. It only exists in a right triangle. And the hypotenuse is the side that is opposite the right angle. So side C is called the hypotenuse. And that is the most important side. Okay? So anytime you have a right triangle, I need you to make sure you recognize right off the bat, label it hypotenuse. If you want to call it hypot, that's fine. All right? Because that is the most important side. The other sides, so this is side A and side B. Sides A and B are called the legs. So we have 2 legs and a hypotenuse in a right triangle. So really, really important that you know the word hypotenuse. So the Pythagorean Theorem is used to find the missing side length on a right triangle. Very important that this only works on a right triangle. And people give you lots of formulas, but I'm going to give you a very special formula because I think it's more important. Here's my formula. Leg squared plus leg squared equals hypot squared. Hypotenuse squared, all right? This is the most important thing, that you take your 2 legs and you square them and then you add them together. And then it's equal to the square of the hypotenuse. And I like this formula much better than the one most teachers give you, okay? Because I think it's more specific. We always want to be equal to the hypotenuse squared. That is the most important thing. The legs don't really matter, okay? How you add them doesn't matter. But just in case you need to know, most teachers write a squared plus b squared equals c squared. Have you seen that before? Yeah, okay. So that's the traditional way to write it. A squared plus b squared equals c squared. I don't like it though, okay? Because it gets, what's the c? You got to know, all right? The c has to be the hypotenuse, and that's the most important part. So I'd rather use words because I like that better. Okay, so you have your calculators handy, ladies and gentlemen. You need to practice with your calculators. Here we go. We need to find the value of x. And again, ladies and gentlemen, you need to write down the equations. You're going to probably figure out shortcuts as you do this. I'm not going to do any shortcuts because this is notes. We don't do shortcuts in notes. But you have a calculator, and most of the stuff is pretty easy. But I do want you to write down your setup. Write down the equations, okay? Because that is the important part. So we want to find x. We're going to round to the nearest tenth when necessary. And so what we want to be able to identify first is the hypotenuse. So we have our right angle. Which number represents the hypotenuse? X. Yeah, our hypotenuse is right here. Our hypotenuse happens to be the x, okay? Which means the other things, the 12 and the 5, those are the legs, all right? The 12 and the 5 are the legs. So what's our Pythagorean theorem? Leg squared plus leg squared equals hypotenuse squared. Does it matter which leg I do first? It's not going to matter. It doesn't matter. So I could do 12 squared plus 5 squared equals what squared? Oh, careful. X squared. All right. So this is our setup. Leg squared plus leg squared equals hypotenuse squared. Now, let's go ahead and figure this out. What is 12 squared? 144. 12 times 12 is 144. What is 5 squared? 25. Okay. And that equals our x being squared. Can I add the 144 and 25? Yeah, what do we get? 169. Very good. Equals x squared. And then I need to figure out what x is all by itself. How do I get rid of a square? This is a long time ago we did this. Root it. Very good. Square root. Yeah, we do. We're going to cancel out a square, we square root both sides. Square and square root cancel each other out. So do you remember how to do the square root in your calculator? So square root is right here above the x squared. And it's blue, so you need to do second square root of 169, and that gives me 13. So x equals 13. So our hypotenuse is 13. It is easy. Let's look at number 2. First thing you need to do is identify the hypotenuse. Where's the hypotenuse? X is the hypotenuse. All right, it is across from the right angle, so that x is the hypotenuse, which means we have our leg and another leg here. And what's our Pythagorean theorem? Leg squared plus leg squared equals hypotenuse squared. So 18 squared plus 15 squared equals our hypotenuse squared. And now we're going to go ahead and clean it up here. So 18 squared is 324, and 15 squared, 225, and again, I'm just keeping that x squared for going along for the ride here. So now we have these numbers we can add together. 324 plus 225 is 549 equals x squared. And then how do we get x all by itself? Square root. Square root. Take a root of both sides. So we're going to do second square root of 549. And so we get x equals 23.4. We'll do 23.4. We're going to round to the 10th place most of the time. All right, is this okay? It's pretty easy, eh? All right, let's just do one more here.
We should do 6.
We will. Well, we one more of these, and so yes, there's more coming. More coming. Let's do number 4. Where is the hypotenuse? X is the hypotenuse. Always the first question. Where is the hypotenuse? Which means the other things are legs. So what should I write for my equation? Equals x squared. Very good. 12 squared plus 9 squared equals x squared. Leg squared plus leg squared equals hypotenuse squared. All right, what is 12 squared? 144 plus 9 squared? 81 equals my x squared. What is 144 plus 81? 225? 225? 225 equals x squared, and then how do I get the x all by itself? Square root, both sides. So x equals
15.
15. Hey, how about that? That turned out nice. 9, 12, 15. That's a nice triangle. All right. Do you have questions on finding the hypotenuse? Is it easy? Yes. So easy. Okay. So now, sometimes it's not quite so easy. Again, the important part is we want to get our setup, our equation correct. So write it same as before. The first thing we need to do is identify the hypotenuse. What's our hypotenuse on number 5? 10. Again, right across from the right angle is our hypotenuse. Okay? The other things are the legs. So what's my equation going to be this time? 8 squared plus x squared equals 10 squared, okay? So again, leg squared plus leg squared equals hypotenuse squared. Let's clean up what we can. What is 8 squared? 64 plus x squared equals, what's 10 squared? 100. So we cleaned up what we could. What do you suppose we need to do to solve for x? Minus 64. Very good. Yep, we're going to move that 64 to the other side. So we get x squared equals, what's 100 minus 64? 36. And then how do we get x by itself? Square root both sides. Square root, the square and the square root cancel. What's the square root of 36? 6, because 6 times 6 is 36. We just want one of those 6s. Okay, so sometimes we just do it straight up like we were doing before. Sometimes we have to solve, get that x by itself, okay? Let's try number 6. First things first, where's the hypotenuse? 25. Yeah, across from the right angle, our hypotenuse is 25. So the other things are legs. What should we write for our equation? 23 squared plus x squared plus equals 25. Okay, leg squared plus leg squared. So 23 squared plus x squared equals 25 squared. All right, what is 23 squared? 529 plus x squared equals, what's 25 squared? 625. Okay, and then we need to do what? The squares? So on my calculator, there's a really easy squares button right here. Yeah, so if you just type in 25 and hit the square button, that's the easy thing. Easiest way. All right. We do need to subtract 529 minus 529 from both sides. 625 minus 529 is 96. So x squared equals 96. And then what should we do to get x by itself? Square root. Square root of 96 is 9.79 or 9.8? 9.8. If we round to the 10th place, that would be 9.8. All right, how are you feeling about this? Good? Will you please try number 9 and number 11 on your own real fast, please? First things first, where's your hypotenuse? I want you to circle your hypotenuse. Circle the hypotenuse. That is the first thing you should do. Find that hypotenuse. And then write your equation. Circle your hypotenuse, then write your equation. Circle your hypotenuse and write that equation out. Then finish solving it. Paper. Good. What do you do last? Nice job. Good. All right. Again, the very most important thing is to equal your hypotenuse. And once you know what your hypotenuse is, then you can write your equation. So the legs squared plus legs squared equals that hypotenuse squared. And for number 11, legs squared plus legs squared equals hypotenuse squared. And then you can solve from there. What do I have to do to get x by itself? Minus 25, very good. So we get x squared equals 24, and then we would square root both sides, so we get x equals 4.9. Very good. Okay. Now, the very, very last thing we have to talk about, questions. Raise your hand if you got both of these correct. Okay. All right. Nice work. Okay. All right, last thing. Testing for a right triangle. I like to do this. Okay, let's see. All right. Let's say I got I want to make a triangle. So I'm going to use my my expo markers here to make a triangle. So I have my expo markers here. I have 3 expo markers for one side of my triangle. I have 2 expo markers for this side of the triangle. If I have 1 expo marker for the third side, does it make a triangle? No, why not? Oh, it's not connected. It doesn't connect, yeah? But wait. But here that works, right? Does that, is that not a triangle? No. Not a triangle. Okay. So it turns out that in order to have a triangle, you can't have 2 of the sides be equal to the third side. The 2 small sides can't be equal. Would it work if I had 2 on 2 side and 2 side? Would that work? Yeah, so I could have a side of 2 and a side of 2 and a side of 3. That worked. Okay, so it turns out that the 2 small sides added together, so I'm going to say the small sides are A and B. The 2 small sides have to be bigger than that third side in order to make a triangle. And we just did that. We said, hey, if I've got a side length of 3, a side of 2, and a side of 1, that doesn't make a triangle. It just doesn't work, okay? They can't equal the 3. They have to be bigger, okay? So if I have 3 expo markers and if I have 2 and 2, then that'll give me a triangle that stands up, and that works just fine, okay? So in order to figure out if we have a triangle, we need to compare the 2 smaller sides, how they relate to the third side. They must be a little bigger, just a tiny bit bigger. So determine if the 3 given side lengths form O. Oh, this is the wrong thing. I need to change your homework assignment. I'm sorry. I was thinking this was something different. Okay, we're going to change this. Determine if the 3 given side lengths form a triangle, not necessarily a right triangle, just any triangle. let's say, here we go. So I want to compare testing for a triangle, not a right triangle. I don't care about that right now. So here we go. The two smaller sides, 10 plus 15, is that bigger than 20? True. Yes. So yes, we have a triangle. Right here, let's pretend that the side lengths were 12 and 20 and 32. Let's pretend that the side lengths of the triangle were 12, 20, and 32. So again, I just want to pick up my two smaller sides. 12 plus 20 needs to be bigger than 32. True or false? False. Because right here I have 32. Is 32 greater than 32? No, it's not. So this is not a triangle. Okay? Good? Okay. That's all we're doing today, ladies and gentlemen.